Welcome to B.Tech. In today's session, we are going to discuss about the interface circuits. We all know what is meant by an interface. So, an interface is a circuit which is going to form as a bridge, or it is going to form as a connection between a slow working device and a fast working device. So, in this diagram, we can see processor is a fast working device and the keyboard is a slow working device. So, to have the data transfer or to have the synchronization between a fast working device and a slow working device, in between we are placing an interface circuit here. So, we can see here we are having this interface circuit, and before the interface circuit we are having the keyboard circuit here. So, for this keyboard circuit, here we are having the keyboard switches. So, in the keyboard, if I am going to press any key, that key will be encoded, and it is being transferred onto the data lines of this encoder circuit, and it is going to be sent to the input interface circuit. So, before sending that, we are going to check if the data is valid or not. If the data or whatever the key that we have pressed, to that the binary encoded information should be equivalent to that binary form. So, in place of 1, any one of the bit is going to change from 1 to 0 or 0 to 1. It is not considered as a valid data. So, if it is not a valid data, simply we are not going to send that data to the interface circuit here. If it is the valid data, then only we are going to send the data to the interface circuit. And now in the interface circuit, the processor is going to check the SIN flag. If it is 1 only, then it is going to transfer the data that is present in data in register onto the data bus, and from data bus the data will be transferred to the processor here. So, to do this all operations, initially processor will also send some signals like to perform the data transfer, processor will places the address onto the address lines, and this address, along with this address, it is going to set the master ready signal, and this address will be placed onto the system bus, and this address is going to be decoded by all the devices that are connected to the system bus, and the address that has been placed is the address equal to the keyboard. So, now the keyboard will sense, it is going to identify the address by decoding that address, and now the keyboard will send another signal that is called as slave ready signal to the processor. So, by seeing this slave ready signal, processor will remove this master ready signal, as we have seen in the previous concept about synchronous buses. There we have seen about that one. So, by seeing this slave ready, now the processor is going to receive the data from the keyboard. So, this is the whole circuit or the operation of this whole diagram, how we are going to perform the data transfer. So, the status flag SIN is clear to 0 when the processor reads the contents of the data in register. So, after the data has been transferred from data in register, simply the processor will places the SIN to 0. So, by seeing the SIN, it indicates that no other character is being transferred from the keyboard here. So, the whole circuit regarding this interface we are going to see in detail in the next slide here. So, we can see in this slide we can see this is the whole circuit that is been performing the input interface circuit, where the processor and keyboard has been connected. In between we are placing an interface circuit here. So, this interface circuit we are going to represent, or we are going to see in an detailed form here. We can see this is the detailed circuit that is present in the interface circuit. So, we will see what happens to this one while we are going to perform the data transfer. As we have said, the processor is being connected at this side to this circuit, and the other side we are having the keyboard here. It has been represented here. So, now the keyboard will send the data onto the data bus, and it will be transferred to the processor here. So, to do that one, initially the processor will assets the data onto the address line. So, we are having the address lines here. So, the address lines are represented from A0 to A31 address lines are there here. So, from A0 to A31 lines, on these lines the address will be placed by the processor. So these address lines are being connected. Here we can see these address lines are being connected to two AND gates here. This is the AND gate 1 and this is AND gate 2. And to these AND gates we are having another signals that are also being connected, that is master ready signal and read by write operation. So whatever the operation we are performing here, accordingly either read or write, we are going to place that particular signal here. So here we are going to perform the read operation from the input device. So that's why the master ready signal will be 1 here, and the read signal is also been 1 here. So whenever we all know the AND gate truth table, that is whenever the inputs of all the AND gates are equal to 1, then only the output of that AND gate will be 1. So by seeing this, so if you are having the read status, so the output of this AND gate 1, if you consider it as 1, and the output of AND gate 2 is also considered as 1 here. Now this signal will be sent to here we are having an OR gate. So to this OR gate we are having two inputs, one is read status and read data. So these are also considered as two control signals, and the OR gate output, if any one of the input is 1, the output will be 1. Simply we are having a 1 at this OR gate output, and to this OR gate we are connected with an tri-state buffer here. So to this tri-state buffer, so we have discussed about this tri-state buffer. So this tri-state buffer is represented in this format. So this is having three inputs. One is called as three terminals. One is input, one is control input, and another one is the output here. So how it is going to work is nothing but, so simply if I am going to send a 1 here at the input, and at the control input I am not giving any control input, say we are giving a 0, simply it is going to act as a high impedance state. The tri-state buffer is going to act as a high impedance state, which means it is going to act as a open circuit. So high impedance is nothing but high resistance. So when we will have high resistance, according to V equal to IR, I equal to V by R, which means we are having high resistance means low current, which means low current means I equal to 0 here. So I equal to 0 is nothing but there is no connecting path between input to output. So simply the circuit is going to act as a open circuit. Now consider the other case here, consider the other case, that is if we are providing input 1 here and the control input is also 1 here. Now what happens to this tri-state buffer? It is going to act as a short circuit. Simply it is going to transfer this 1 onto this output side. So we are going to have a closed path here from input to output side, and we are performing the data transfer from input to output side here. So similarly we can see here we are having the control input 1 here, and the input to this tri-state buffer is given as 1. Now the output to the this tri-state buffer is given as 1 here, which means the tri-state output to this the tri-state output for this one is considered as slave ready. So which means slave device has sent the slave ready signal to the processor when the data when we have decoded the address, and accordingly if that the slave device is having the same address, then only we are making the slave ready signal to 1 here. So after sending the slave ready signal, we have to send the data onto the data lines. So for that we are going to check if it is a valid data or not. So for the data is valid, then we are going to send this sin is equal to 1. So if the data is valid, then only sin is equal to 1. Now to this tri-state buffer, the control input is given as status read status. So the read status, the AND gate output is considered as 1 here. So this control input is also 1 here, and it is sending the output signal as 1 here. So by this we are going to transfer the data that is present on the data in buffer register onto the data lines in the processor. So we can see here, so the data in is present here. From this we are sending the data onto the data bus here. So this is what represented here, the data in register, and from that the data is being transferred onto the data lines. So this is the whole operation that is going to be done when we are going to perform the data transfer from the keyboard to the processor. Whereas coming to the next operation, we can see we are going to perform the data transfer from processor to the output device. So that is nothing but printing to the processor connection. So here the processor is going to perform some data transfer from processor to the output device. So for output devices are also we are going to have the same thing, another output interface circuit similar to the top input interface circuit. So the interface circuit will consist of data register, data out register, and a status flag S out. So we are having data out register and S out flag, and initially we are going to consider S out is equal to 1. When S out is equal to 1, processor is going to simply perform the data transfer from processor to the printer here. So here we can see the direction of data transfer is in this direction. In the previous topic we can see the direction of data transfer is in from keyboard to processor direction. So we can see this one here, how we are going to perform. So in this also the processor has to send the address to the particular device. So here the printer address is been placed by the processor on the address lines, and by taking this address lines we are going to send the master ready signal also. Along with that we are going to send the write signal to the processor to the printer, and now the processor is waiting for the slave ready signal. So the slave ready signal will be given whenever this printer is ready here. So whenever the printer is ready, the slave ready signal will be given to the processor. By seeing this slave ready signal, processor will perform the data transfer from processor to the printer here. So for this also we are going to see the interface circuit. So the interface circuit is represented in this format here. So here also we can see the same thing. In this we can see that the same output interface circuit is being given here. So this is the complete output interface circuit which being represented. So as we have discussed while transferring the information from keyboard to the processor, here also initially the processor we can consider here the processor is present, and here we are having the printer here. So processor will initially sends the address onto the address line. So according to the address, and along with that master ready signal is also been sent here, and along with that we are sending the write signal also here. So by seeing this one we can see the write signal is being given as 1 here. So the read status is going to be 1 whenever the output of this AND gate is equal to 1. Similarly, the load data here we can see here in the previous presentation we have represented this one as read data, but here we are loading the data to the output device. So for this AND gate 2 also the output will be 1 whenever the output device is ready. So depending upon these two gates outputs we are going to place the slave ready to 1, and here also the tri-state buffer input is continuously given as 1. So the slave is ready now, and we are going to perform the data transfer by having these two. If it is idle or not we are going to check, and we are going to send, and according to this S out signal we are going to place the data from the data lines onto the data out register, and if it is valid data only, then we are going to perform the printing operation. So this is what we are going to perform when we are using the output interface circuit here. Okay students, we will see the last one, that is in the interfaces we are going to have the data transfer may be done in two ways. One is serial and another one is parallel. So whatever we have discussed till now in the previous topics may be considered as the serial data transfer, but we are having the parallel interfaces circuits also, where the data will be transferred parallelly. So here also we can see the data from P0 to P7 as D0 to D7, and we can perform the data transfer in a parallel manner, means at a time placing the data from sender to receiver or from receiver to sender also we can perform the data at a time, but in the previous two cases it may be done in a serial way. So these are the two ways where we can perform the data transfer in asynchronous type of buses. So students, we will see the next class, the next topics in the next session. Thank you.